The U.S. dental industry generates over $160 billion in annual revenue, yet it remains one of the most financially inefficient sectors in healthcare. This chart compares the American Medical Association's general healthcare claims error rate to the specific dental first-pass denial rate. At 15%, 1 in every 6 dental claims comes back rejected, requiring immediate rework. The American Dental Association estimates that the average dental practice loses 10 to 20% of its potential revenue to claims processing inefficiencies. For a single practice producing $1.5 million annually, the math is brutal. Factoring in a 15% denial rate and a 50% appeal failure rate, that practice loses between $150,000 and $300,000 in unrecovered revenue every year. Most practices respond by increasing administrative staff hours to file appeals. However, only about half of dental appeals ever succeed, turning that labor into a sunk cost. Scaled across the 200,000 U.S. dentists, this leakage represents a $10 billion market of lost capital. The dental industry is facing a structural data engineering problem that passively bleeds billions of dollars from its clinical operations. The mechanical precision of a clinical dentist collides daily with the blunt, automated nature of insurance payer approvals. This revenue leakage is a syntax error. Clinicians dictate clinical reality, identifying decay and recommending a crown. Payer algorithms require rigid justifications mapped to specific coding guidelines. When an accurate clinical note like "recommend crown on tooth 14" hits the payer's algorithm, it is immediately denied. But translated into the required syntax, carious lesion requiring restorative intervention per D2740, the claim passes seamlessly. Practices have historically relied on retroactive denial management to fix these errors. With over 200 CDT code changes since 2020, that manual approach is now statistically ineffective. Capturing the lost $10 billion requires a system engineered to make the zero-defect claim a mathematical certainty. To solve this, EDiFi looks to advanced manufacturing and zero-defect engineering. The platform is built on DMAIC, an acronym for Define, Measure, Analyze, Improve, and Control. This framework is the core of Six Sigma, a methodology used by corporations like General Electric to drastically reduce defect rates. EDiFi transforms the dental claim into an engineered product flowing through a Six Sigma pipeline. This 12-stage claims pipeline replaces the chaotic workflow of manual entry with a rigid, standardized sequence. The define and measure phases establish baselines. Before treatment begins, the platform automatically verifies eligibility and scores the probability of the upcoming claim. During the analyze and improve phases, an AI layer intercepts flawed data. It identifies denial patterns and automatically enhances clinical narratives to match payer requirements. The control phase acts as a systemic guardrail. It prevents any substandard claim from ever reaching the submission node. Applying DMAIC shifts dental revenue operations from human guesswork to quantitative machine control. The probability score is the vital sign of every individual claim in the EDiFi pipeline. This gauge calculates the mathematical likelihood of first-pass acceptance. Here, an initial claim scores 82%, triggering a yellow warning. The engine evaluates 5 weighted factors instantly: documentation completeness, historical success with the payer, code accuracy, payer rules compliance, and clinical necessity. The system provides actionable tips to reach a perfect score, prompting staff to add missing periodontal charting or specific radiographs. Using the auto-enhance function, the platform generates the required insurance-optimized narrative and validates the codes. The dial moves immediately to 97%. EDiFi holds claims until they reach a probability greater than 95%. This targets a process sigma level of 4 or higher, a statistical threshold where fewer than 6,210 defects occur per million opportunities. Submitting a claim becomes an act of mathematical certainty, computationally verified prior to submission. Achieving perfect claims does not increase the administrative burden on the clinical staff. Clinicians simply dictate their natural observations into a microphone at the conclusion of a procedure. Within 60 seconds, the platform transforms raw audio into structured data using a medical-grade transcription node. The AI extracts clinical entities to generate 4 data streams: a SOAP note, subjective, objective, assessment, and plan; the doctor's narrative, CDT procedure codes, and ICD-10 medical diagnosis codes. These streams converge into a payer-optimized narrative. It satisfies both clinical truth and the insurance algorithm without manual keyboard entry. The automation enables cross-visibility between hygienist and doctor workflows, identifying conflicting notes that often cause automatic denials. As the hygienist records findings, EDiFi shares real-time periodontal data and code suggestions with the doctor. This ensures documentation for procedures like D4341, scaling and route planning, is aligned before the doctor enters the room. This process automates the translation of human clinical observations into machine-readable financial demands. Scaling this process offers compounding leverage for dental service organizations, or DSOs, managing hundreds of locations. EDiFi deploys 5 specialized AI agents across the network to manage eligibility, claims optimization, denial prevention, revenue recovery, and practice intelligence. This creates a portfolio intelligence effect. When the AI identifies a denial pattern at one location, it propagates the corrective behavior to every other practice in the organization. Running AI at this scale requires a foundation of absolute HIPAA compliance, the federal standard for protecting sensitive patient data. The platform utilizes a zero-trust architecture. It employs row-level security, or RLS, a database method that ensures every multi-tenant practice's PHI, or protected health information, remains isolated and encrypted. EDiFi is a secure intelligence layer that syncs with legacy practice management systems to upgrade the capacity of the entire network. Predictive denial prevention is the solution to the industry's historical reliance on reactive management. The engineering targets are clear: a first-pass acceptance rate greater than 90%, denial rates below 5%, and eligibility verification performed 50% faster. These targets address the $150,000 to $300,000 in recoverable revenue that an average practice loses every year to legacy inefficiencies. EDiFi engineers uncertainty out of the dental practice. Every claim is computationally verified before submission, ensuring every dollar of earned revenue is collected.